Okay, sorry about the bug that hit us last night. That's one of those things that happens when you're using, developing the software. So let's get back to the Minsky model that you guys hopefully didn't go as far as me in putting together the bits and pieces and causing that bug to appear. But I'll just bring up my Minsky and start it again, and just do the one bank. What I want you to do is have just the banking sector's view, and you have I'll just run a little movie here and show it to you again. Oh, hang on, that's not the movie you want to show. Pardon me. So let's go back and create a single bank icon. Call it the banking sector. Just going to check and see what I had in terms of accounts there. Reserves, loans to firms, deposits, firms. Okay. So, hang on. So, make it large enough to see the window properly. I'll have reserves here. Then, I'll just make it simple to have loans. So, we won't make it loans to firms. It's just a bit of labour. If I wanted to have lending to households or lending to workers as well, then I might have something different, but I'll make this firms deposits because you can have other assets for the firms as well. Workers deposits, and then just call this bank. I won't try to have multiple banks, so that's the bank as a shorthand for bank equity. And then I had 1,000 as the reserves here, and meaning that when the bank starts operation, it starts with only equity. No assets, no liabilities. Starts with just equity, and then you have lend to firms. So that means this is going to be, again, to make it simple, I won't include the possibility of lending to other organisations. It's just the word lend is fine. And then hire workers. So that's going to be wages coming out of the firm sector and going into the bank account of the workers. You've got to pay interest, so that's interest coming out minus int out of the firm's account and INT going into the bank's equity. Then workers consume, so I just use the underscore W to make it lowercase. Oh, by the way, I'm going to make a mistake here deliberately, just to show you what Minsky does. I should have had a minus sign there. I didn't. So we've got taking money out of the workers' account, putting into the banker's account. Minsky comes out saying the sum is minus 2 times consumption of workers. So it's showing an error. So you can go back inside and just use the arrow key, go along and type a minus. And Minsky fixes up the error. So it doesn't stop you making an error, it just points out that you've made an error in terms of stock flow consistency. And then if I have banks doing buying goods, then I'll have minus buy underscore B from the banks, and that means they're buying stuff from firms, so buy underscore B here, and then finally repay loans, so that's going to be minus repay coming out of here, and that also shows that there's a minus repay on the loan. So Minsky's making sure everything is correct there. Has anybody here done accounting? Okay, well you can actually have it in debit and credit style as well. Okay? All right. So, and we took a long time to work out ourselves what the standards were. We had a while where we actually had the wrong standard. The logic was correct. The standard in terms of accounting and pluses and minuses was different. We made sure there was a plus and a minus on every row. Now you can have minuses on 2 minuses on a row if you're reducing assets and reducing liabilities, 2 pluses if you're increasing assets and liabilities, which is more natural too when you think about it. I still find it hard to understand the debit and credit style. It's quite tricky, as you know, but the plus and minus is quite straightforward.
How do you change it?
Pardon?
How do you change it?
Huh?
How do you change it?
Under options, you have debit and credit style. And also under options, you can show what the flows are. Notice there's no flows going through these accounts right now, so the equal sign there is saying what the flow is in and out of the account. Since the sum of all those are 0, you're getting 0 turning up here, but the initial conditions are still shown as 1,000. Okay. So I'll turn off debit and credit style. and that's what I'm more used to. And so once you've done that, what you've defined is a set of differential equations over here that give you, let's get this thing working. Okay, give you all the logic that you would, I tried doing this occasionally using the flowchart programs, and I'd always make an error, always stuff up. There was no double checking. The double entry bookkeeping lets you check and see what your logic is, so it makes life a lot easier in terms of designing a complex set of accounts. And as I noted, even though I had that stuff up with the model yesterday with the reserves, you can make the interlocking double entry bookkeeping accounts. And if you have like two banks, you might have like a bank for the financial sector and a bank for the real sector, or a bank for workers and a bank for capitalists and stuff like that. Then the transfers will turn up 4 times. And of course, in that case, there'll be money moving through the reserves. So the reserves are playing the interbank settlement role that they actually do play. They played in Minsky as well. So we've got that done. Now what I want you to do is to start defining the variables, because if you look at the equations right now, there's no value given to all the elements here: buy, consume, interest, all the flows are 0. So you want to define the flows in some sensible way. Now, the most obvious thing to do is to define the interest flow as the rate of interest on loans times outstanding loans. But the first trick in doing that, let's go run this little movie backwards, pardon me, is you've got to actually grab all the flow and stock elements on the Minsky table there and put them on the canvas so you can edit them. So you just copy the flow variables as a right-click menu option, copy the stock variables, the same thing. They come across inside groups, you then ungroup them, and then you can edit them. Okay? So that's the next stage, what I want you to do. So go to your model, go to the Godley table, right-click, and one of the options there is copy flow variables. Click on that. You get a group, right-click and choose ungroup, and there are your flow variables, and then right-click and choose copy stock variables and place them up here and ungroup, and there are your stock variables. So you can now define them all. Now I'm going to whack reserves out of the way for a while, because I'm not going to use reserves for quite some time. But loans, and I have interest payments. So just grab hold of loans, drag it down somewhere, grab hold of interest, whack it on the level, and now you want to define interest payments. Well, it's going to be the rate of interest, and I'll have R underscore L just to emphasise that it's loans. Make it into a parameter, give it a value of say 0.03, maximum of 0.2, minimum of 0.01, step size of 0.01. So you can vary it as you wish during the model. Press the multiply key and wire loans to the top, RL to the bottom, bang, and now you've defined rate of interest on loans. If you take a look at the differential equations, you've now got part of this defined. You've got a new parameter, rate of interest on loans, and interest is equal to loans times the rate of interest on loans. Okay, so it's quite straightforward to do that. Now, the next point here is, just having done that, so that's just, I've just shown you that, just repeating the little movie there. I think I'll jump over that movie. Now, how do you define the flows themselves? Because rate of interest times loans is pretty obvious. What about how do you define wages? How do you define purchases by consumers and so on? The way that I prefer to do it, it's not the only way by far, but I think it's the most intuitive way, is to say that the flows are based on the stocks. Okay? And the simplest way to base them on the stocks is to say that there's some flow rate linking the stock, the flow to the stock. And I'll take one of the simpler ones, consumption by workers. I would base consumption. You could base consumption by workers on wages. So you could simply say, for example, and I'll do this now, that workers consume all their wages just by wiring the two together. And I could equally say that banks consume all their interest earnings by wiring those two together. Now that's pretty much a Koleskian way of doing it. Okay, workers consume all their wages, capitalists invest all their profits, and so on. I haven't got lend and repayment affected yet, but I'll do that in a moment. But let's just say that lending That's what I've done I've got to check what I did in the lecture here. Did I use time constants straight away? Okay. What I want you to get you to is what are called time constants. I'll just explain those using the slides and then come back and do it live on Minsky. But in engineering, a whole lot of calculations are done using time constants, which tell you what's the time response of some system. And what a time constant is if you had a constant rate of depletion of some stock from initial point to like if you hit it to like a straight linear decline, then the time constant tells you how many time units it would take to get to zero. So, for example, let's say you've got started at 100, you've got a rate of decay of 100 per year in a straight line. That will get down. You get down to zero after 1 year. But what you've actually got going is exponential decay. So you start off with the actual decline rate starts at 100 per year, and then because the amount is dropping, it becomes whatever amount is outstanding per year. So you get an exponential decay. You don't reach zero instantly. So I'll take you through the logic of that. So they're a measure of how long something would take to either fall to zero if it's negative or double if it's positive, and there were no other inflows. Okay, of course there are other inflows. Let's say, looking here, I'll take you through a rate of outflow from firms. I'm going to argue that wages are some outflow of money from the firm sector. And that's pretty obvious. Firms are paying wages using the money they've got in their own accounts, so it makes sense to relate the wages to some rate of turnover of the amount of money in a deposit account. If I make that constant 1, then it's a 1 year. If there's no other inflows into the firm's account, in 1 year it would be empty paying wages. That's the basic idea. So I'll just actually whack that into Minsky here. So I've got firm's deposit here, and I want to divide that by a time constant. I'm going to go \tau, which is the Greek letter for t, underscore f, and give that a value of 1. Make it a parameter, give it a value of 1, say a maximum of 2 and a minimum of 0.2 and a step size of 0.1, and divide the firm's deposit by that, and link that up to wages, which are down here. I'll just grab wages and drag it up. Hang on. Because that's using control click to drag them around. So that's relating what's in the firm deposit account back to wages and giving you consumption of workers as well. At the moment there's zero in those accounts and nothing will happen. Okay, there'll be no change. But that's the basic idea of using a time constant. So there's a time constant for the turnover, the amount of money in the firm sector, and that tells you how many years it'll be until the account's emptied if there are no inflows and the decay was a linear decay. Now, what I've set up here is I've actually put 1,000 into the deposit account of the firm sector. So I can do that by saying, for example, there's 1,000 there in the deposit account and 1,000 of loans as well. That gives me balanced initial conditions. So if I do that, I'll just actually now quickly graph over here what consumption of workers is. And I'll graph what's in the firm's deposit account. Now, this is not the way I design a model normally. I'm mucking around here. It isn't going to work well, but just giving you an idea of how to start defining a model and using Godley tables. In fact, it's stabilising. If you take a look at the Godley table itself and look at the values, you find that wages are going out at 1970, consumption's coming back at 1970. There's no change in the amount of money in the firm sector because it's all circulating around. Okay, so if you actually want to illustrate what I'm talking about here, what you just do is say, well, it just goes straight into wages and there is no consumption, so I delete that wire. Okay, now let's run it and see what happens. Boom. Firm sector disappears, but it doesn't fall flat down to zero. Notice it takes 5 years to get there. Okay, that's because if you drew a tangent from here down, then it would hit the 1. And I'll show you that in a moment. But because the money's flowing out, it's like exponential decay. It takes a while to taper down. So I'll look at 3 different rates here. That's if I have a level for the tau of 1 year. And notice if I draw a tangent from 1,000, then it hits at precisely 1. But the actual rate is an exponential decay rate. Then if I have 2 years, then it hits, or a half a year, it hits at 0.5. Now we then make it 2 years, then the tangent hits at 2. Okay, and the increase in the amount of money goes to the other sector. So the advantage of time constants is it's stating what's happening in an understandable time unit. Because when I first did these models, I was multiplying the amount of money in the account by a constant rather than dividing. And for workers, for example, I'd say workers, I'd use a time constant, say, of 26. And what that meant was the amount of money in a worker's bank account turned over 26 times a year. And Mark Lavoie looked at that and said, why is the number greater than 1? Because he wasn't used to time constants. Well, I had to say it's because it's how many times it turns over. But if I use 1 over 26, then I'm roughly using a value of 0.04, and that's saying that the workers' accounts turn over 0.04 of a year. Okay, and that makes much more sense, and then it's actually an understandable quantity. So time constants make a very consistent way of using numbers throughout an account. So like if I use, say, a time constant for workers of consumption of, say, 1 over 26, roughly 0.04, what do you reckon I should use for bankers? Bigger number or a smaller number? If a banker had no money coming in, how long would they survive? Weeks or years? Years. Okay? So you use a larger number for the bankers because they're wealthier, and therefore the amount of money they have in their account turns over more slowly than the workers. So most workers couldn't survive without a paycheck every month. Their bank account would be empty. A poor banker in that same tragic situation might last a year or a decade, So you use a large number. What about firms? The amount of money in the firm sector, how often should that turn over, do you think? Should the turnover rate be a small number, meaning a high rate of turnover, or a large number, meaning a small rate of turnover?
Small number.
Pardon? Small number. Yeah, if you look at Marx got a bit exaggerated than that, but he was talking about money turning over 12 times a year. So in effect, if you look at Capital, when he's talking about, I think it's Capital Volume 3, he goes into discussions about the rate of turnover, which is extremely wise of Marx to have that. Most economists weren't thinking in those terms at all. He was actually thinking in the rate of turnover of money and talking about the MCM plus process. But he used turning over 12 times a year. Well, that'd be one hell of a fast-working firm sector. So I use about 0.25 to 0.5. So we actually do that. Then you have a definition of the throughput through the firm sector. Now, at the moment I've connected that to wages, but I want the models I'm doing here are totally monetary. I don't have any production sector in them. You could do that by having another section with the flowchart logic and linking the amount of money turning over to physical goods and so on. You could have the wage rate in the Goodwin model affecting the wage bill paid in the Godley table, etc., etc. All those things are possible. But to make simple points like this about monetary dynamics, I tend to make it all based on the monetary sector. And therefore, how do you think I define GDP? Think about how you define GDP. What are the methods for defining GDP? Income, expenditure, and production. Okay, so I can't have production definition in this because I haven't got but I can have expenditure and I can have income. Okay, now income's workers, capitalists plus bankers. Okay, expenditure is really what's being spent to buy goods and services, and that is the turnover of the money in the firm sector. Okay, so my definition of GDP, I'll just make this a bit larger so you can see it, and these simple models, is to have the amount of money in the firm sector divided by how often that turns over. And again, this is it's an artificial thing. It's just, if I wanted to tie the whole model together, and that's what you'll see that Pedro and Nick have done with the more elaborate models, then I'd have causal factors affecting what the turnover rates are and so on. And I'd have expenditure. I determine using expenditure by bankers and capitalists, if you like, on the firm sector. There's a lot of sophistication to what you can do. These are basically toy models that I'm doing here. But I have firm sector's deposits divided by the turnover in the firm sector is GDP. And wire that up. And then again, this is much simpler than I would do for a more elaborate model, but again, it's to make the point of monetary turnover. I then have profits being a fraction of GDP. Okay. Now, if you look in the Goodwin model, profits are a residual after paying of wages and interest on debt. So again, you could make that happen in a more elaborate model. But to make it simple here, I simply say there's a fraction that goes to workers and a fraction that goes to capitalists. So if you S for a rate of surplus, stealing an idea from Marx, make that a parameter and say give it a value of 0.3, so 30% of GDP goes to capitalists with a maximum of 50% and say a minimum of 20% and a step size of 0.01. And then if I multiply S by GDP, that's now defining profits. And if I subtract profits from GDP, because interest payments are made out of profits in that sense, then I get wages. And then having done that, wages therefore given me, now I could just do the Koleskian thing and say all wages are consumed, okay? But what I prefer to do again is to show how rates of spending determine GDP, say that wages then increase the amount of money in the workers' deposit account, and there's then a rate at which workers spend out of the deposit account. So for that I use tau underscore W, and give that a low value like 0.04, which is roughly saying workers spend everything they earn in a week. Let's say a maximum value of say 0.2, so they might last 2/5 of a year, and a minimum of say 0.02, so they can just last 1 week. 0.04 is like lasting a fortnight. Different step size. I'll go back to making that into a parameter. So workers' deposits divided by the rate at which workers consume gives you consumption by workers. And then if you look at, let's just scan out here. This is a very messy diagram. I wouldn't do this when I was defining an actual final diagram. But take a look at the equations. What haven't I defined? All I haven't defined so far are lending and repayment. Okay, I've got a definition for banks saying banks spend all the money in their account. I'd like to change that as well. So with bank, I can just, that's the bank account. I can just say there's a rate of consumption by bankers tau underscore B, give that a value like 1, which means they could spend for a year without going broke. Say a maximum of 5, minimum of 0.5, step size of 0.1 is okay. And then divide that by bank, and I've now got how much bankers are buying. And all I need is lending and repayment to work out what they are. Now, the simple way that I, again, cover that in this model is to say that lending is based on the amount of money in the loan account, and repayments based on the same. So if I say there's some rate of lending tau underscore L, now what I'm talking about is a constant that will tell me how long will it take the level of bank debt to double if there's just lending going on and no repayment. So a rough rule of thumb I use for that is something like 7 years. 7 years to double the amount of, which means about a 10% rate of growth. Actually, I better, where is that? Where did tau W go just then? Where did I put it? Pardon me?
It's in the profits.
Pardon?
Between GDP and profits.
Thank you. Notice it's hard to select that thing there? My mistake, okay. So now divide that by so that's not lending I want to divide it by. I want to define lending that. Control Z, by the way, reverses the last action you made in case you delete something you didn't want to delete. So I divide loans by tau L, and I now get lending. And then equal, I've got a rate of repayment, so I take a copy of loans and divide that by tau R, and give that a value initially, say the same, say 7, and a similar range, maximum 20 years to repay debt, say minimum 5, step size of 1. And so loans divided by a rate of repayment gives you the level of repayment. And now I've got a model where I've defined all the stocks and all the flows.
You forgot to
Sorry?
connect the tau workers to the...
Yeah.
Oh,
I've got workers' deposit matched. Oh, yes, you're right. Thank you. Okay, good. So there's consumption by workers. Just look at those two accounts and see what happens with the model. And what happens if you increase the rate of lending? So the lending happens more rapidly, and you show lending happening more rapidly by reducing the time constant. So rather than taking 7 years to double the amount of debt, it takes 6 years. Okay. Oh, that was repayment, I hit, pardon me. And notice if you increase the rate of lending, you increase the level of economic activity. If you slow down repayment, it increases even more. So let's just look at GDP. I'll just stop that and just graph GDP. So this is now GDP, which time dimension is years, and the value is dollars per year. And start with lending and repayment at the same level. And great, that bloody bugger's turned up, so the screen's gone blank on it. So I've got to click on it and just drag it a bit until such time as the, oh dear, bugs.
Maybe try to zoom out or something.
This is really being helpful here. Finally, okay. So now let's reset the scale and see what happens. And if you increase the rate of lending, the GDP flatlines initially because ultimately the rate of repayment equals the rate of lending. But if I have faster level of lending, then GDP increases. And if repayment happens more slowly, it increases even more. Repayment goes the opposite direction. So you've got a world in which changing the rates of repayment and lending change economic activity. Okay? That's the real world. It's not the world in which neoclassical economists live. So let's take a look at their world. So that's a very simple way of showing the dynamics of the system. That's just a few further illustrations of the role of time constants and so on. Now, I'll just jump over this bit here. So what we've done is create a fully connected model where all the time constants are filled in. So if you bring up that slide yourselves on your computer, you can just click on that icon and that'll load the model, which is a rather better designed model than I did on the fly just then. That'll load it in the release version. It won't be loaded in the beta version. You've got to load that independently. But that gives you the overall logic that I've shown you mucking around very quickly there. And I've put the controls for lending to firms and repayment by firms in the top right-hand corner, as well as the control for how rapidly money turns over in the financial sector. Okay. Now, if you run this model, and you have no net creation of new money, ultimately all the accounts stabilise. So what I'm graphing here is loans to firms are constant at 1,000. Deposits of firms are rising because some of the money is being spent by banks. Banks start with 1,000 in equity and in the model initially. So the amount of money in the bank account of the banks is falling. The amount going to workers is rising because they're being hired by firms and having jobs and so on. And you then have ultimately incomes all flat line. And now if you increase the rate of lending by reducing the time constant, you increase GDP and increase the bank accounts as well. So money actually changes the amount of economic activity. Lending is not a transfer of money from one person to another. It's a creation of additional money which creates additional spending power which is spent by the recipient. So that's the real world. And it's extremely easy to illustrate that real world in Minsky. You vary the amount of money. Credit and GDP move in the same direction. So it's not a pure redistribution. So what are the neoclassicals missing? Why are they getting it wrong? And it comes down because in the loanable funds model, all you're doing is transferring money from one non-bank to another non-bank. There's no change in the assets and or liabilities of the banking sector. There's a change in who they have liabilities towards, whose deposits they're holding, but there's no change in the absolute amount of money. That's not the real world. This is their fantasy world of a patient person lending to an impatient person. And therefore, what it means is you can have huge changes in the level of debt in their model and no real impact on the real economy. Unless there's any huge differences in the spending power of the groups that are borrowing and lending, which is Bernanke's point. So if you look in the real world, a bank loan increases both assets and liabilities equally. That's what they're missing. That's when they say because somebody's asset is somebody else's liability, therefore money has no aggregate effect. They're leaving out that assets and liabilities can rise and fall in tandem. They're just not even looking at the money creation process. But when you create new money, it's spent by the borrower and it expands aggregate demand. So this is the point which, I am the first person to work this out properly, but Richard Werner as well, so Richard and myself, but both worked out that credit plays a role in aggregate demand, and we still haven't got it through to our fellow non-orthodox economists, let alone to the neoclassicals. Okay, it's one of those weird things.
What do they say then? I mean, when you have these
presentations
in front of neoclassicals, are they just like, we don't like you, we don't trust you?
Yeah, pretty much. I mean, that's if they even turn up. Like I've given presentations where they're in the audience, and I mean, occasionally I've caused them to gasp. There's a shock reaction. They didn't expect that, particularly with the empirical data that I show. But generally speaking, they just dismiss it. Oh yeah, interesting model. What's next? So it's like, again, it's you're showing something that's outside their mindset. But if they actually accept what you're talking about, it's a bit like somebody who believes in the Catholic religion being shown the skeleton of Jesus Christ. It's such a change to their belief system they won't accept it.
And I would also argue they can't grasp how important this is.
And they all the importance as well. Yeah, so they say that it's an artifact. Okay, it's mildly amusing, but that's the end of the story. They don't think through the consequences.
Yeah.
But every one of them. I mean, there are.
Oh, there are different. Michael Kumoff is an exception, but Michael already knew of the stuff before Michael and I met. So, like Michael, can't be talking about Michael's work later. We're good mates. We're close friends. He was trained in DSGE modelling. He's a whiz at DSGE, which of course I don't have any time for DSGE, but it's difficult. I will never argue that it's easy. So he's got quite skillful at building DSGE models. And he said before he became an academic, he was a banker. He said he knows he created money. He made loans. He created money. So when he came to being told how to do the modelling, he accepted the modelling technology he was taught in mainstream economics. But he said, look, banks create money, so if I'm going to build a DSGE model, banks are going to create money in it, and that's going to create aggregate demand. So he's fine. But what he's now finding is he's getting the same brick wall treatment that I got when he goes speaking to Neoclassical. So they turn up to his meeting because they won't bother going to my seminars because I'm presenting non-DSGE models. They go to Michael's and he presents DSGE models and he's still getting the same sort of reaction that I get, which he finds really shocking. I'm used to it. But she said the main thing is they can accept that you can do the model, but they don't think through the consequences.
Yeah. Like literally from my open letter experience.
Sorry?
From my open letter experience, when I had the discussion, there was a professor saying, well, what you stress, that this is economics, and you're stressing this.
Yeah.
And I said, well, but this has an importance for this.
Yeah.
So it's all built on this. So it has huge importance, but he couldn't grasp.
Yeah. It's just it's a Gestalt problem. They simply can't perceive what you're talking about, because to perceive it properly would completely change the whole approach to thinking about the world. And so they shut down. It is. You occasionally get somebody say, "We'll really flip," and like that. Again, I really understand the experience that Max Planck went through, because Max Planck was the person who gave us quantum mechanics, and the way he did that was that there was a problem in physics at the end of the 19th century called the Blackbody radiation problem. And that is like any physical thing that's above absolute zero is radiating heat, radiating some energy. And when you look at the spectrum of the radiation, it's like a pimple. It has a look across the frequency spectrum. The level of energy has got the shape of a pimple between low frequency and high frequency. With Maxwell's equations, you could fit one side of the slope or the other side of the slope, but you couldn't get the hill. And so Max set himself the task of solving that, and it involved what's called integration in the complex plane. So when you do it, like you've all done integration with university, okay? You're integrating over a physical distance, like from 0 to 10 years or 0 to 10 metres, that sort of thing. Integration of the complex plane uses complex numbers. You integrate around A plus I times B. It's complicated mathematics and something you learn in second year mathematics courses, but it's certainly doable, but it's challenging. So he used that approach and he solved the Blackbody radiation problem. He could fit the curve precisely, but he had to invent the idea of energy coming in small units, the idea of quanta. Now that's part of our language these days. People talk about a quantum leap, which is crazy because a quantum leap is an incredibly tiny distance. Max Planck's, I think it's 10 to the minus 27 metres is the Planck constant. But it was a huge leap for him because he went from moving energies perfectly smooth, a wave which can have any frequency at all and come in any amplitude. Suddenly you're saying it's got to have a fixed amplitude. Okay? It must be units of 10 to the minus 27 times, etc., etc. But it solved the problem. And he said he tried to convince his fellow academics who'd been trained in Maxwell's theory of electromechanics, and they couldn't comprehend it. They would not accept it. And that's why he came up with a wonderful line. And I've got to read some Max Planck. I've just realised this the last couple of days because he's got some great one-liners. Okay? So his classic one-liner is science advances one funeral at a time. Okay? And he says a new discipline succeeds not by convincing the exponents of the old to change their mind, but because the exponents of the old gradually die and the young come up who can accept the new idea. And frankly, that's exactly what I'm experiencing here, not at the same level of mathematical complexity, obviously, but that's what's going on. So when they all die, this might get accepted, but the trouble is they reproduce themselves in an academic setting. You only get if you go to Cambridge, you won't learn any of this. By the time you come out after 4 years of doing stuff at Cambridge and do a PhD, you're locked into it. So they continue reproducing themselves no matter what. And the only hope I have is, characters like yourselves and finance firms who can't afford to be stuck in ideology. So a lot of them end up employing people like yourselves because they want people who can be realistic about the role of credit and money in the economy. But the academic thing is almost, it's impossible.
But even when you show them how well your models fit the data, they say it doesn't matter, or because you model something, the data you compare, and it turns out something. So what do they say? I cannot believe
they don't even turn up. They treat me as a monetary crank. So they won't even turn up to my seminars. Okay. So there'll be events like like I'm speaking at the NIESR conference in September, and because they're a conventional economist in the audience, then if I was talking about credit, then this would turn up. But they turned down my funding application for cycles and instability, so I'm talking about sustainability instead. So in that audience, I'll have neoclassicals, but they won't hear me talking about money. But normally when I speak at a seminar, there are no neoclassical academics in the audience. Or if I do, I gave one presentation at the last INET conference, which was a dreadful conference, since no time for feedback. I had to actually leave before one of the two discussants on my paper spoke, who was a mainstream Cambridge economist. He just dismissed the logic, even though I had some of the data there where the only explanation for the data was my logic. So, yeah, it's frustrating.
Would you come to Cologne and discuss with the professor about your stuff?
Well, yeah. Yep, absolutely.
We could arrange that because.
Yeah, it's happily come along.
There are professors who are willing to discuss things, and we had also pluralistic lectures.
Yep, if they've happily come along. If you arrange it, yeah.
I think there are professors who are interested in discussing things. It's not just they say,
I remember Krause, he was the Schirmherr because none of the other macro guys wanted us to do it, but he was willing to do it. The Schirmherr shot was important. We need a professor at the University of Cologne to say, this is what the guys are doing as academics, basically, in order for us to give other people credit points. But even him, again, the first time they approached him, we didn't really know who they were, like clueless. He hadn't really heard of them. He was, right, do your thing, and then he came, and I remember after he came to the first few lectures, and at some point now, he didn't turn up anymore, and even though he accepted to do it a second time, he never turned up to a lecture again.
I think he turned up more often than 2 times.
No, I went there when I was the organizer of the second one. The first time he came to about half the classes, and then he stopped coming. The second time he didn't come at all. And even though he was for sure there. But that's just because he's a guy who can't say no.
Just a quick thing on one of my ex-students, Nick, is now doing shadow banking modelling at the Bank of England. He wants to come on at 11 o'clock our time to do a presentation about how he's used Minsky. So is that okay? We've got 9 till 10:30 here. When do we start again for the second session? At 11 o'clock? 11, okay, that's here. Okay. So make sure you're here at the very beginning. If we get here, say 5 minutes to, okay?
Yeah.
Okay, that's done. All right.
You can't really believe the level of ignorance, right? You can't grasp the level of ignorance.
Yeah.
Okay.
Get used to this.
Give it a try. I'm happy to come along. If you want to come to Cologne, you can arrange it. We'll see what happens. Okay. I'll give a more compressed version of what I've covered for you guys in the last few days. Monetary modelling and then the financial instability hypothesis and complex systems.
So Sounds interesting.
Yeah.
Start by
Okay.
having him reading the empirical paper by Richard Werner and see what he's saying.
Pardon?
I suggest he should start by having his professor read Richard Werner's empirical paper and see what his response will be. Like the empirical paper where he shows balance sheet. If it is loanable funds, balance sheet would like this, but they observe how the balance sheets of the real bank actually end up. It's a balance sheet extension, so it's only
But even so, I mean, that's the Bank of England and the Bundesbank have already done that for us. Okay, so that wouldn't necessarily change their minds because they've been, like, there's been 4 papers so far by Neoclassicals discussing that result, or 4 papers considering endogenous money. 2 of them use what are called overlapping generations models, and both of those conclude no impact. Okay. 2 DSGEs both concluded say there's an impact. They'll just stick, there's no, it's undecided.
Okay.
They'll ignore it and keep on going. So I think it's better to show the macroeconomics of it, which I can do.
Yeah, sure.
Yeah. Now what I want to illustrate is, this is something that it wasn't just Neoclassicals I had this problem with, because again, even in the Post Keynesian group, it was very hard for anybody to see how credit played a role in aggregate demand. The block being that expenditure is income. And what I was saying initially was that expenditure is GDP plus change in debt. Now that's, strictly speaking, that's wrong. Okay? But if 100% of borrowed money was spent buying assets, then it would be right. Okay? So I was making a sort of empirically roughly correct, logically wrong, precisely wrong idea. What I finally worked out is a way of getting precisely right, both empirically and logically. The trouble is the empirical data doesn't differentiate between the turnover of existing money and money newly created credit. Okay, so you can't pull the 2 out in the way I would like to, but now I've got an empirically valid, watertight argument as to why credit plays a role in aggregate demand, whether that includes or doesn't include expenditure on assets. So that's what I want to go through now. You all know Basil Moore? You don't know Basil Moore? Okay. Look for work by Basil Moore on the endogenous money stock. Basil's the person who really began the modern endogenous money literature. So what I've been arguing throughout, it made complete sense to me, but giving a properly logical argument took a long time. The credit has an impact on the macroeconomy. So here's a logical analysis using effectively sectoral balances. Divide the economy into 3 sectors, and each sector, of course, is spending on the other 2. And show this in a table where on the horizontal you've got expenditure, on the vertical you have income. Therefore, on the diagonal, you've got the expenditure by one sector, money coming out of its account, going into the other 2. So you have a negative on the diagonal, and the negative on diagonal is equal to the sum of the positives on the off diagonal for each row. So each row has to sum to 0. This is something we intend adding to Minsky, maybe with this funding, maybe later, depending on how much time it takes to do the other elements. It's an analytic tool rather than a design tool. So the columns can be non-zero because you can expend more or less than you receive back in income, but the aggregate must be 0. Okay? And you have to look at 3 possible arrangements. One where there's no lending, which I call Say's law. Loanable funds, where there's lending between the sectors. And to show that properly, what you've got to have is, like any transfer along a row is expenditure. Now, a loan is not expenditure, okay? Nor is it income. So the loan I show along the diagonal, okay? And then bank-originated money and debt it's not a transfer between liability accounts. It's an asset being created on one side of the bank's ledger and then create liability of exactly the same value on the other side. So when I bring at the bank, I bring in an extra column for assets and an extra column for the bank. And let's see what happens. So with when you have just the Say's law situation, sector 1 is spending A plus B dollars on sectors 2 and 3. Sector 2 is spending C plus D, sector C, E plus F. If you take the negative of the diagonal, the sum of the negative of the diagonal, you get aggregate expenditure. If you take the sum of the off diagonal, you have aggregate income. They're necessarily equal. So there's expenditure by sector 1. That's who it's spending it on, so that necessarily sums to 0. That's income for sector 1, which can differ from their expenditure. But in the aggregate, everything sums to 0. And this is one of the reasons we work with gross rather than net, because the net is zero. Okay? So that's effectively the quantity theory of money, because you've got aggregate demand is identical to aggregate income, and it equals effectively the turnover of existing money. There's no new money being created there. So if I had $100 in each account, and each sending $100 per year on the other sector, then the velocity of money would be 2, okay? And you'd have a total GDP of 600. So that's aggregate demand. And if you then take the negative of the trace of that matrix, that adds up A plus B plus C plus D plus E plus F, which I can say is existing money times how often it's turning over, so it's basically Milton Friedman's MV. Okay? Now with loanable funds, Sector 2 lends to Sector 1, and that's shown as a flow along the diagonal. And then Sector 1, of course, has to pay Sector 2 interest, because if there's a flow of new debt, there must be outstanding debt. So you're paying interest on the outstanding debt. And Sector 1 then spends that borrowed money on Sector 3, because you don't borrow for the sheer pleasure of being in debt. Okay? So you show that, and I'm calling them credit and interest here. So credit is paid from Sector 2 to Sector 1, and credit is then spent by Sector 1 on Sector 3. But because that flow is happening, there's less expenditure by Sector 2 on Sector 3. And what you see is credit turns up as a positive and a negative on both when you look along the horizontal and you look along the diagonal in both ways. So credit cancels out. You do the mathematics, credit cancels out. So I'm using a symbolic mathematics program here to show that if you just take the negative of the trace and do the same substitution, credit drops out, but interest does not. Because interest is expenditure here and an income there. Okay? So it turns up as interest only appears once on the diagonal, only appears once on the off diagonal. Credit appears twice in both, once positive, once negative, therefore it cancels out. Okay? So credit plays no role in aggregate demand if you're working in loanable funds. And that's what neoclassicals do, and that's what they'd prefer to do. Okay? Not have to consider the role of credit in the economy. So and this is the intriguing thing, if they were right about the structure of the banking sector, then their macroeconomics would be correct as well, because you could ignore debt.
Could you come again on the interest rate argument?
Pardon? Yeah, that's one I didn't expect, okay? Because when you think about interest, it's gross interest. Interest is part of aggregate expenditure, okay? And it's not just net interest, it's gross interest. So if I had deposits being paid as well, loan interest and deposit interest would both turn up as part of aggregate expenditure and aggregate income. I thought they'd cancel out, but I tried it and I was wrong.
That is what I expect as well.
I didn't expect it. So if you do the logic yourself, you'll see the same result. If you imagine that the bank is paying interest to each of those accounts, then gross interest payments turn up as part of GDP. Yeah. Okay. It's nice when you get a result you don't expect and it doesn't contradict your overall logic.
Yeah.
Okay, that's what I got there. So I didn't expect that result, but it made sense when I thought about it, and it still didn't undermine the main point I was trying to make, which is the role of credit.
Sure.
So if you now have the bank creating credit by changing the amount of debt that Sector 1 owes to the banking sector, then the asset of credit rises. There's therefore credit turning up as additional money in Sector 1's account, which Sector 1 is spending on Sector 3. Okay? And then when you do your sum negative of the trace, I should have made that red as well. There's your creation of credit, there's the expenditure of credit, and you do your trace and you find credit as part of aggregate demand and aggregate income. So it's all completely watertight logic in terms of expenditure is identical to income. So that is something which I proved. It came out of a debate I had with Mark Lavoie and Tom Pally and Brett Feiberger, mainly in response to a comment from Brett Feiberger. I don't know that they've actually read my reply, and my reply is much more complicated than the argument I'm showing you now. And I know that Randy Ray hasn't read it, and I know it's not part of the MMT literature, but it should be, because it shows that credit as well as having to look at government money creation, you have to look at private money creation, because they both change the amount of demand in the economy.
What's the name of the paper?
Good question. I think it's called a reply. It's in the Review of Political Economy, and I used a much more complicated way of showing it. I had time constants times amount of bank accounts, and it was very, very messy to look at. This is a much simpler way of presenting it, which I haven't put this in a published paper. Okay, so it's not part of the literature, but it should be. And what it shows is that credit is part of aggregate demand and aggregate expenditure, even if you're not looking at a world in which you're buying assets. Because you look at assets as well, most money that's borrowed is borrowed to buy assets. So what you've got is your expenditure, your idea of expenditure now has to expand to include the financial sector. So you can't separate the financial sector completely, like hermetically, as the Neoclassicals do, from the real economy. So credit doesn't cancel out. So banking, therefore you can't ignore it in macroeconomics. And it's also the most volatile component. Okay? Income and expenditure change much more slowly than credit does. And that's, even though credit's a smaller part of aggregate demand than expenditure out of existing money, because it's so volatile, it dominates the trend. So I'll just put some of the people who've made these sorts of arguments beforehand, including Schumpeter. Even Pigou understood the role of credit in the economy in the 1920s better than Keynes did. But this is looking, now what you have to look at is both credit and total private debt as major factors in the economy. And this is data I've reconstructed using the Federal Reserve and census data going back to 1834. And it's even let me identify a crisis that I didn't know happened, which of course was major when it occurred. We've forgotten about it. It's the crisis of what's called 1837, or the Panic of 1837. And you see there's a massive fall in the level of private debt across that time from a much lower level. But when you look at that in terms of what the rate of change was as a percentage of GDP, it was down at credit was negative 10% of GDP for about 5 years. Now, that was a huge existential crisis for American capitalism, that experience. And it went even lower. Intriguingly enough, when you look at it, it doesn't look like there's much difference with that to that, but that had a massively negative credit. That only had a small amount of negative credit in it. It's quite intriguing. You really have to look at both credit and debt to understand it. There's the Great Depression. Again, minus 10%. And there's the Great Recession. Not as deep, not as long, but still negative credit. So it's an incredibly important explanation of economic performance. That's why you simply have to take account of it. And MMT, as I said, will be strengthened by taking this into account. It's not a criticism of MMT. It's saying if you add this to your logic, you've got a richer explanation for the monetary.
Go further.
Yeah, no problem at all. Now, when you look at credit versus unemployment, again, neoclassicals think there's no correlation. Well, I'm saying there's a causation. And this is, if you even looking over since 1880, which is a ridiculous length of time, 140 years virtually, you get a correlation coefficient of minus 0.3, which according to them should be 0. They ignore it. Now, when you have a high level of private debt as we have right now, it's the highest in history, the correlation becomes ridiculous. And this is the graph that's caused gasps when I've shown it at various conferences where there are neoclassicals in the audience, because according to them, there should be no significant correlation between those two variables. Well, it's bloody minus 0.85. Okay? They would be at cock a hoop to get a correlation coefficient of that scale for any of their own models. You know, this is just one variable to another variable, and they say they have no relationship to each other. They're virtually inverse plots of each other. Okay? And it also extends to the finance markets, because when you take a look at real household debt and the real house price index, that's the sort of pattern you get. By the way, this is using Robert Schiller's excellent data series on American house prices, with 1890 being set to 100, and you see for virtually a century, not a lot of change in the index, and then bang, That's the subprime bubble and bust, and now we're up to again, and that's the level of private debt, household debt across that period of time. Now, I haven't put the logic in this particular paper, but I argue that, putting it simply, most of the demand for houses is new mortgages, which is a change in mortgage debt. If you want to convert that into a flow of demand for houses per year, you divide by the price level. So you have a relationship between change in household debt and the house price level. It takes a bit of mathematics to work it out, but you then get a relationship between acceleration in household debt and change in the house price level. And the correlation coefficient over the last 110 years is 0.4, which is stronger again than I find even for the unemployment data. Now, when you take a look at the last 30 years or so, correlation coefficient is 0.7. So this is the strength of the data the Neoclassicals are ignoring. Okay? They collect this data, and it's statisticians in central banks that they staff who collect this information. Thank God Copeland put the flow of funds table together in the first instance, because he did understand the importance of money. Otherwise, we wouldn't even be collecting the stats. But we do collect the stats, and they simply ignore them because on a priori grounds there should be no significant correlation. And that's all they come up with. So
only correlation means not a lot. I mean,
sorry? Yeah.
Only correlation does not mean a lot. I mean, there can be partial correlation or control for other factors, so there might be no correlation at all anymore. So
that's
not convincing.
One of the worst phrases ever invented is correlation is not causation. Because people say that you show them a correlation coefficient of 0.7, well, they say, oh yeah, but correlation is not causation, let's ignore it.
Why?
That's what they do. It's one of those happy little phrases economists are happy with throwing forward. If you get a correlation like that, particularly if your a priori is telling there should be no correlation, then you've got to dive in and say, well, is there a causal explanation, or is there a causal link between the two, or is there some intermediate factor? And instead, that's just a little... I mean, I've heard that phrase so many times it drives me bonkers, because rather than saying... If you seriously took the correlation is not causation argument, what you're saying is you've got two things which are correlated to each other, but some other factor is causing them to both change. Okay? So you should therefore say, well, if your a priori said there should be no correlation, which is what the Neoclassical's a priori is, then you should seriously go and investigate what might be the third factor.
Of course, yes.
They don't do it. They just say correlation, not causation. Yeah. That's it. Complete failure to engage.
There's so much econometric analysis which tries to investigate these relationships.
Yeah, they don't even look at the data. I mean, I would love to see a Neoclassical pull this apart.
I would not. Yeah, I don't know. But that sounds too easy to me, to be
Pardon?
honest. That sounds too easy to me, to be honest.
Yeah, unfortunately, that's all the reaction I get.
But by a correlation coefficient, you will never convince anyone.
No, but we've done Granger causality on this, for example. Okay? Which is, again, Granger causality is not a good enough... Granger causality is a very tough test because that presumes an exogenous shock to a system to give you a result. And says, well, what's the causal? Is X cause Y, does Y cause X? And we get a 15-to-1 ratio between the two in terms of mortgage debt causing house prices or house prices causing mortgage debt. 15 times stronger in the mortgage debt to house prices than vice versa. So we have done the work. I haven't had a chance to... I've been... a joint paper which I simply haven't had time to do my part of writing up the history of the literature on, so I can send you a copy of that if you like. Okay, so it's very strong causal analysis, and again, that's why I went through the causal argument with the rate of credit, with the first bit. That's a logical argument. So logically, credit plays a role in aggregate demand.
And data fit the logic. And then data fit the logic.
Huh?
And then the data fit the logic.
The data fits the logic. Fundamentally, that's what I'm doing. So it isn't just like I haven't just grabbed the stats and said, look at these stats, they make my case. I've got a logical argument, which is the role of credit, creating part of aggregate demand. And then most of that credit goes into asset prices, so it turns up in the data. So, it's different. Have you read the classic, let's take the con out of econometrics by Beamer?
No.
You haven't? Okay, have a good look at that paper. Because a lot of econometric testing it's inadequate to be able to differentiate between different theories. It's and even like with the Granger causality, the problem about that, it's got a very linear perspective on what causation is. With a feedback system, you can have something appears to happen after something else is actually the causal factor. Like when I show you the Goodwin model, everything is causing everything else in that model. So I don't think econometrics has got enough power to differentiate causal factors independent of a causal argument, but there's a causal argument behind this. So, but I'll send you the paper we've done, and you can have a look at it. I wish I had a chance to publish it, but unfortunately my authors wanted me to do the historical work on the literature on house price, and I simply haven't had the time to do it. Let's go back to Minsky. What this all shows is that Minsky had an innate focus on the role of credit and debt in the economy, and it was entirely justified. It wasn't something which you can criticise as neoclassicals do, as saying that it's... I was just looking for calls from Skype, let's see. Their a priori grounds were not correct. And if you look at where Minsky came from, looking at his references, there's no mention of Keynes until after, I think, about 1967. He accepted the textbook version of Keynes up to that stage and literally talked about the Keynesian assumption that investment is controlled by the rate of interest, which is Hicks's ISLM model. He was really influenced by Fisher. So this is a paper in 1963, a really pivotal paper, Can It Happen Again? And Fisher's there as a reference, Gurley and Shaw, Dusenberry, but no Keynes. So what he was really trying to do was to explain what Fisher started with, was the explanation for the Great Depression being too much debt and deflation. Minsky was trying to explain how do you get back to that point. And it's intriguing looking at Fisher as an author on this front as well, because he developed an equilibrium theory of interest rates. And it's part of me sticking my diary. I'm looking for when Pedro's supposed to call in. 10:15 it says. I'll just see if I can give him a call. Hang on a second, because I want him to show his modelling to you. I'll give him a call. Let's see. You might be expecting me to give him a call. Not online. Oh well, maybe you're not going to manage to see Pedro, maybe later perhaps. Okay. So I'll finish up with a bit on Fisher here, because when Fisher was doing, what Fisher did was to develop a supply and demand model of finance. And he was the precursor to the efficient markets hypothesis. So before Thammer and French and Sharp and friends, if people talked about the role of finance, they had the supply and demand analysis coming from Fisher. And he had made two assumptions that were essential. Like, to make this work in ordinary commodity markets is easy, in a sense. To make it work in finance is really hard, because you've got to say that its markets are cleared through time. So you see in that. And secondly, because when you buy something, you have a physical transfer of money for a physical transfer of goods. In this case, you're promising to pay in the future. What if you don't fulfill your promise? So he made the assumption that all markets are cleared with respect to every interval of time, and debts must be repaid, which is a great assumption to make, as long as you don't apply it in the real world. And he was actually a very successful inventor. Have you ever heard of what's called a Rolodex? Okay. It's a circular machine that has names on index cards, and you can roll it around and find where the names start with A, B, C, D, E, and so on. It was the iPad of its time. He invented it. He sold it to the Rand Corporation, was paid in shares and money, and he had about $100 million worth of shares in terms of $2,000. So he wasn't a billionaire, but he's quite wealthy. He was wiped out when the stock market crashed 10% on Black Friday in 1929. And for a while he was really, accusing the market of being crazy and speculators causing all the trouble and stuff and so on. But he ultimately realised that what got him in trouble was thinking in equilibrium terms about the economy. And he said, he wrote this paper, I really do recommend you read The Debt-Deflation Theory of Great Depressions. And he said, the economic system contains innumerable variables. To imagine that they're in equilibrium is the only way you can actually have them in equilibrium. Your imagination, not the real world. He says you can have this imaginary world of ideal equilibrium, which may be stable or unstable, and disequilibrium. He said the former is statics, the latter is dynamics, and that is an incredibly important insight which neoclassicals today still don't get their heads around. Because he's saying if you're going to do you're going to be dynamics, you've got to be out of equilibrium. Okay? Neoclassicals stick with this idea of dynamic equilibrium. This just doesn't make sense. So he started off by saying you can assume that most things tend towards an equilibrium, and therefore you will converge over time without disturbances, but you'll very rarely reach that point of equilibrium, and in fact there's always going to be disturbances. So logically speaking, even if you believe equilibrium tendencies apply to everything, at the same time everything will be either above or below its ideal equilibrium. Very simple but very deep insight. They said therefore there must be over and under this, over and under everything else. At any particular point in time you'll be in a disequilibrium situation, even if you believe equilibrium is the organising principle of your economy. So he's nowhere near the writer of Keynes. This is probably his best sentence, saying it is as absurd to assume that the variables will remain in perfect equilibrium as to assume the Atlantic Ocean will be without a wave. And that's exactly the same context as Keynes's comment about the long run, by the way, which is always misquoted. So he said, what deviation will cause a crisis? And he finally said, in great booms and depressions, the two factors are over-indebted to start with and deflation following soon after. And that was the experience of the Great Depression. So Minsky really saw, Minsky's vision was to see that in Fisher and say, well, Fisher's explained how if we get to this situation, then there can be a Great Depression. What he tried to say is, how do we get that situation in the first place? And his logic was, again, this is the thing I quoted to you in the last lecture, the natural starting place for analysing the relation between debt and income, was a relationship which neoclassicals don't believe exists, is to take an economy with a cyclical past, which is now doing well. And then you have a debt structure that inherits, that it has, which includes a period where it didn't do so well. So there's a crisis in the recent past. But because you're now being very conservative about your level of exposure to debt and credit problems, only conservative projects are going to be funded. Because the economy has recovered, most of them are going to succeed, so people will learn it pays to be in debt. It pays to have levered investments. And because of that, you look back and say, well, the margin of safety we had was too high. So therefore you would drop your resistance to debt, and you have an increased level of debt financing, and that will increase investment and drive up asset prices. And this is the classic statement. Stable growth is inconsistent with the manner in which investments are determined in an economy with debt-financed ownership of capital assets. So the fundamental instability of a capitalist economy is upward. The tendency to transform doing well into a speculative investment boom is the basic instability of a capitalist economy. And that's what I saw as the true genius in Minsky when I first read him back in 1987.